Hi, my name's Mike Barley. I'm the Territory Manager for Aeroflex's GPS simulator product lines. Thank you for taking a few minutes today to become familiar with our newest GPS simulator product, the GPSG1000. I hope that you will find this video to be a valuable first step in understanding the utility of the GPSG for the integration, validation, and test of GNSS receivers for a variety of applications. The GPSG1000 from Aeroflex Test Solutions is a portable and ruggedized single-carrier multi-channel simulator for testing GPS and Galileo GNSS receivers. The GPSG1000 can simulate a single 3D point in time or simulate 3D dynamic motion by utilizing the available 6 or 12-channel configurations. At its very affordable price point, this simulator fills the market gap between low-end single or twin-channel simulators and top-end developmental simulators. The following video is an illustrative introduction into the GPSG1000's functions and capabilities. We will demonstrate the performance of actual static and dynamic simulations in subsequent videos to follow. Upon removing the GPSG1000 unit from its rolling, hard-sided storm case, one will recognize a series of connectors along the top of the unit. The labels for most of these connectors are indicated on the back side of the unit. Starting from the left to the right side of the GPSG1000, the connectors function as follows. The GPS RX antenna is the external antenna connection for the GPSG1000's internal GPS receiver. The GPSG has an integrated GPS receiver. The receiver's almanac data can be updated or refreshed over the air using this receiver antenna included in the GPSG1000 storage case. The GPS Transmit Direct is the RF output for direct connection to a GPS receiver under test. The GPS Transmit Antenna Coupler is the RF output for connecting to the antenna coupler. The GPS Antenna Coupler is the method by which the GPS 1000 simulates in over-the-air mode. The red Aeroflex Antenna Coupler is placed directly over the antenna of the receiver under test, isolating it from outside interference and preventing the GPSG1000's RF output from interfering with other surrounding GPS receivers. The ref-in 10 MHz is a BNC connector used to connect the test set to an external frequency standard providing a TTL signal. The ref-out 10 MHz is a BNC connector providing an output of the internal 10 MHz reference oscillator. The aux port is a 26-pin D-type connector providing additional auxiliary outputs and inputs. The AC in port is the connection through which the test set is connected to AC power and through which the internal battery is charged. The GPSG1000 may be used while the battery is charging. The Ethernet port, located above the ref-in and ref-out BNCs, can be used for software upgrades and for remote operation. The GPSG1000 is a software-defined instrument. Therefore, any future upgrades to the unit providing additional capability or performance will be accomplished through software modifications or additions and will not warrant the unit's return to the factory. The USB host 1 and USB host 2 are stacked together and also above the ref-in and ref-out BNCs. These USB ports are standard ports allowing for the connection to USB memory devices or network cables. The USB host ports can be used for downloading software to the GPSG1000 to export or import dynamic route files or be used to update the test set with most current GNSS almanac data. The USB OTB port, located next to the stacked USB hosts, could be used to connect multiple GPSG test sets. Finally, in the middle of the backside of this unit, one can locate and remove or replace the test set's lithium-ion battery. Turning the test set around so that the front panel is facing the operator, the protective cover for the GPSG's touchscreen can be lifted and rotated to the back of the unit, thus functioning as a stand so that the test set can be stabilized upright on a flat surface. Pressing the button with the green power logo, located on the lower left edge of the front panel, will begin the power on boot sequence of the GPSG1000. The power on booting process for the test set takes about 3 to 4 minutes total. The booting sequence and progress will be indicated by an SYS LED located next to the power button blinking in blue. A series of software loading procedures will also scroll across the bottom of the touchscreen. Once the booting sequence is complete, the GPSG1000's gray launch bar will be visible. Also, the SYS LED will change to a steady green light. The only other LED on the front panel of the test set is the battery LED, which will illuminate and flash green when the test set is operating under AC power and when the battery is charging. Pressing and holding the power button again from this point will trigger the test set's power off process. Once the power on booting process is complete, an operator would most commonly utilize the gray launch bar to access the various functions of the test set. A common first function to select would be the setup function from the launch bar menu. Touching the gray launch bar will cause the menu of functions to expand onto the touchscreen. Touching the gray launch bar again will cause this menu to contract into the left margin of the touchscreen. Let's access the GPSG1000 setup page by touching the gray launch bar again. Pressing the Setup selection on the launch bar menu takes the operator to all of the setup options for the GPSG1000. Once in the setup function, note the title of the user interface page on the bottom left-hand side. For every page in the test set's user interface, the title of that page will be displayed in the lower left-hand side of the screen. Across the top of the setup page, there are 4 setup selections: Simulation, Channels, I/O, and Motion. Touching the blue area around any of these 4 selections will allow us to enter a setup option for that selection. For example, when we first enter the setup page, the Simulation selection is highlighted in white. This means that we can edit the setup options for the simulation capability of the GPSG1000. Touching the blue I/O field allows us to switch over to the setup options for the RF input and output capabilities of the test set, and so forth. In any of these setup screens, the choices made remain in memory until physically changed by the operator. From any of these screens, a field outlined with a white border can be changed in some way. A field outlined with a blue border is fixed and cannot be manipulated. This is a common theme throughout the entire user interface of the GPSG1000. Any field bordered in white can be changed. A field outlined in blue cannot. In the simulation setup page, and throughout the rest of the user interface for that matter, there are basically 2 types of data entry that can be utilized. One is fixed menu selections, the other is numerical data entry. For example, on the simulation setup page, if we touch the GNSS field on the screen, a menu of options will appear, which are the only choices for that setup field: GPS, Galileo, or GPS and Galileo. Touching any one of these 3 menu options will constitute the selection for that field. On this same setup page, if we then touch the Simulation field, we will see that our choices here are for static or dynamic simulation. A static simulation will be a single 3D point in space: latitude, longitude, and elevation. A dynamic simulation will be a series of preset or user-defined latitudes, longitudes, and elevations, which equates to simulated motion of an object through a variety of waypoints. For the purpose of this video, we will only cover user interface and functional pages for now, leaving static and dynamic motion simulations and their corresponding setup protocols for a subsequent demonstration. The RF level field in the simulation setup page gives us another data entry type method which can be used throughout the GPSG's user interface: numerical data entry. Touching the RF level field on the simulation setup page will prompt the numeric keypad to launch nearby. We can change numeric values for RF level by clearing the data from the keypad and by re-entering a value by touching the appropriate numbers. Note, we have now changed the RF level signal strength out of the test set through the antenna coupler to -95 dBm. Remember, while we have mostly focused on the simulation setup page here, the basic concepts we've just discussed remain the same throughout the rest of the GPSG1000's user interface. Touching the bar triangle round icon in the lower right side of the touchscreen will allow the operator to exit the setup page, or any functional page for that matter. We can also exit the setup page by touching the gray launch bar and selecting another function on the launch menu. If we touch the gray launch bar and touch Simulation function on the menu, we are taken to the page from which our static or dynamic motion simulations are run. Note that the fields in this page outlined in blue are predefined in the setup process and thus cannot be changed. Depending on the type of simulation selected during the setup process, we simply touch the Run field in the lower right-hand side of the touchscreen to initiate the chosen type of simulation. If we touch the gray launch bar again and select the SVPRN function, we are taken to a page where we can selectively manage or manipulate the signal coming from various satellites used in a given simulation. For example, if we touch anywhere along an individual line for an SV, we are taken to a page where we can turn on or turn off that satellite signal, change the health status, manipulate Doppler error for that satellite, and so forth. The route function on the gray launch bar allows us to load and manage waypoints, or routes for a dynamic motion simulation. When a route is selected and loaded, the test set will validate that route automatically, telling the operator that a physically valid set of points have been selected. The waypoint function on the gray launch bar is used to configure the waypoints that comprise a 3D navigation simulation. The GPSG1000's canned list of waypoints consist of cities and corresponding ICAO airport codes and their coordinates. However, other user-defined waypoints can be created and saved to this library of coordinates. Note that the list of waypoints can be scrolled using the indicators on the right and bottom edges of the screen. The GPS RX function on the gray launch bar may be used to maintain, manage, and/or load a current almanac, location, or UTC for use in simulations. The remaining three choices in the launch bar menu are utilized for system status or versions, maintenance, and calibration of the GPSG1000 and can be covered in a more comprehensive overview of the test set. These functions and their usage are also detailed in the GPSG's operations manual, which is provided on CD-ROM with any new GPSG1000 delivered. Thank you for taking a few moments to learn about the GPSG1000. I hope you found this introductory video to be useful. If you have any additional questions or should you require any additional information about the GPSG1000, feel free to contact us via the internet at our website at www.aeroflex.com.